Arun sir, is I audible?
Yes, sir, audible.
Yes, sir, audible.
Thank you very much, sir. Good evening, one and all. I am Dr. M.D. Sirajuddin, co-coordinator of this FDP. I welcome you all on behalf of Vaageswari College of Engineering to this 6 days faculty development program. Without wasting much of your time, it is my pleasure to invite our speaker of today's session, and I would like to introduce him, Mr. Pathan Karimullah sir, Senior Software Engineer at Concentrix, Hyderabad. With over 15 years of rich industry experience, Mr. Pathan sir has specialized in designing, developing, and deploying enterprise-grade applications using Java, J2EE, Spring, Hibernate, and microservices. He has strong expertise in CI/CD pipelines, Docker, Kubernetes, GitLab, and cloud platforms like Amazon Web Services, Azure, and Google Cloud. Mr. Pathan sir is also an Oracle Java SEB certified programmer, and he has successfully worked with leading clients including HCI, IBM, and so on. He brings proven skills in end-to-end development, debugging, deployment, and so many microservices. We are truly honored to have him with us today to share his insights on quantum cryptography and its impact on cybersecurity in the digital age. I welcome you, sir. Thank you very much for joining us. Thank you very much. So over to you, sir. Karimullah, sir.
Yeah, thank you, Mohammed Sirajuddin, introducing me on behalf. Yeah, hi everyone. This is Pathan. As everyone knows, like Mohammed Sirajuddin given the overview of my profile. Yeah. So today I'm just going to share the knowledge on this cryptography and its principles of quantum cryptography. So basically, before going to start, I just wanted to give you a high level background of cryptography. So as we know, like to share any confidential information over the internet or in the digital world, so we have so many techniques to share confidential data over the internet or in the digital world, right? So cryptography is one of the most popular way of sharing the secure, sharing the sensitive information over the internet, which we call them basically. And here earlier we use different techniques to share the sensitive information between the source and destination. So there are a couple of ways to do it. So one of the most popular way is cryptography. There are a couple of ways we can achieve this using like symmetric key and asymmetric key cryptography and hashing and digital signature. So everyone aware of the symmetric key cryptography like we used to do using AES advanced encryption standard. For example, if we have a like in every microservice architecture, we just need to connect to the couple of applications, a couple of tools like Kafka, Redis, DBs, and all. So not only the programming, so we just need our programming has to be communicated with the different tools. So for every tool connection, we need a connection string, right? So that connection string is nothing but a sensitive data. So if that connection string is revealed, then hacker or someone third party authorities can then access the data and then they can view and then alter the data in the DB or in the other tools like message exchanges like Kafka, other brokers, right? So in order to secure the data, we have these techniques as of now, right? So for example, if you want to connect to the MySQL DB, so the DB is having username and password. So whenever the junior developer comes, he doesn't know about it, and then he just hard-coded the username and password to connect to the DB by using any programming language. So that is explored to outside. So if something happens and if something goes wrong and then the hackers or someone third party who is not having authority, then they might use or misuse the information that is there in the detail. So that is, it is important to secure those kind of informations in IT industry, right? So for that reason, the cryptography is one of the most popular technique to secure our information using either AES or RSA or by hashing or by digital signature. So these all are we are actually now we are following. But when it comes to quantum computing, so quantum computing is more means like the classic the quantum computing is more faster than classic computing which we are currently in. So the quantum computing is not implemented full-fledged as of now, but in future quantum computing would implement 100%. Then that will impact our this whatever the techniques which we follow to secure our information, right? So to overcome that, we just need to work on the quantum cryptography aspect. So I'm just going to present quantum cryptography related principles and things how we can achieve and secure our information. So I'm just sharing my screen. Just let me know once you are able to see my screen. So I hope my screen is visible to all of you guys. Someone raised their hand. Hope my screen is visible, everyone. So here I'm just presenting the screen. Just let me know once you're able to see my screen.
Yes, sir. It is visible, sir. Please continue.
Yeah. So here this is quantum cryptography principles and techniques. This is we can get how we can achieve securing the confidential information using quantum cryptography. So we know already there are a few cryptography mechanisms which we are currently using, but this quantum cryptography is just related to the quantum computing. and how we can secure the sensitive information over the internet or digital world. So here are few agenda items which I am going to discuss today. So what is the fundamentals of quantum cryptography, and what is the difference between quantum and classical approaches when it comes to the cryptography, and quantum key distribution. It's a major the major key item which we are going to discuss, and implementation and challenges while implementing. Okay. So the first is, what is quantum cryptography? Quantum cryptography is a security approach that leverages the principle of quantum mechanisms to create theoretically unbreakable encryption systems. So earlier we discussed already. So there are a couple of approaches to do a cryptography. There are so many mechanisms which are available and currently we are following, but this is also one of the approach to create theoretically unbreakable encryption systems. Unbreakable in the sense, so like public key, private key sharing and accessing the confidential information. If there is a possibility to get the public key, private key by the hacker, but here we just overcoming the existing whatever the implementation technology mechanisms which we have. So there are some possibilities the quantum computing will break that the secure communication. So here in the quantum cryptography, we just enhancing whatever the problems which are there in existing, and then we just wanted to overcome using these quantum cryptography principles. See, unlike traditional cryptography, which relies on mathematical complexity, quantum cryptography bases the security on the fundamental laws of physics. So, this is quantum cryptography is completely based on the fundamental laws of physics. So we know already the quantum theory. The quantum theory will follow the photons and neutrons, electrons, which transmit through a medium. The medium is nothing but a fiber optic cable or something, some other medium, and it will make a strong connection established between source and destination. So here also in quantum cryptography, the fundamental laws of follow the fundamental laws of physics. And the primary goal is to create a communication channel that are secure against any computational attack, even from quantum computers themselves. So the primary goal of this quantum cryptography is to create a communication channel that are very secure against the attacks, even from the quantum computers. So everyone knows about quantum computers, right? So which are currently the most of the companies are investing, and even India also having the separate channel to invest implementing quantum computers. Google, IBM, and many Fortune companies are investing their feature in quantum computing, because so quantum computing is more faster than the classic computing which we currently doing. So how it works means, I hope everyone knows, like the classic computers will have only zeros and ones, like for example, if you write a program, a sample program, it will convert the compiler will compile the code, and then it will translate that human readable language into a machine level language, and then it will execute the instructions which are being written in the program, and then it will give us the result, right? So in quantum computing, that is something different. So we know, like we have the identical state of 0 and 1,